Good afternoon, everybody, and welcome to this webinar on beam design. My name's Tommy White, and I will be taking you through all the different options you have on beam design today. I just want to give you a quick overview of what the MasterSeries is and what we do. We have three product ranges. We have the big building design suite. The Watermans and the likes are all using this to design their buildings. And then you have the smaller PowerPad suite for doing small buildings and elemental work. And then finally, if you just want one module to do beams or connections or masonry, you can purchase that on its own, and we'll be looking at all those options. So we'll be looking at these individual options, but also how they apply to the PowerPad as well. So our modular suite of analysis is portals, beams, frames, and we can then add on wind and CAD and finite elements and dynamic and seismic analysis to that. And then we can add on steel, concrete, composite connections and timber design. And finally, masonry, retaining walls, pile caps and RC detailing. But today, all we're going to look at is a small bit of frame analysis, our beam designers, and some steel, concrete and timber design. So these are the areas that we are going to look at today. What we're going to be looking at from a commercial point of view is our beam designers for doing steel, concrete and timber beam design. Very powerful programs, and they're ideal on their own, or if you have a large network license, they're also ideal as additional licenses, so you don't have to have a big multi-story frame analysis engine just to do simple beams. An example of that would be, again, the Watermans would use the concrete beam designer and the steel beam designers, quite a lot of those, as well as all the frame and big building designer suites. So they mix and match to suit their needs. So that's the beam designers. You also can do simple beam design in our frame analysis with the steel, concrete and timber design modules. And the frame analysis comes in four sizes: 50, 500, 1500 or unlimited members. And from a commercial point of view, doesn't matter which one of those you take. If you need to upgrade to the next size up, it will always be just that difference in cost between the two. So as you grow, that will grow with you. PowerPad is a separate system, and it includes versions of these beam designers for handling a 1 to 3 span beams. And it includes the frame analysis up to 100 members for doing your steel, concrete and timber design. So if you had a 100-member continuous beam, you can do it in PowerPad. And then the third option is looking at the free software, which we will look at the end of this webinar and cover it slightly, is the simple beam designers for doing 1 span steel and concrete beam design. And also the frame analysis can do 1 span analysis of steel and concrete. So what we will not be covering today is the composite beams and its sister program for doing slim floors. They come into the composite beam webinars because they're a specialist subject. This gives you a broad idea of what you can and can't do with each of them. And obviously with the free versions, you cannot do continuous beams unless you have the full versions of the programs, either the beam designers or master frame. Likewise, if you want to apply axial and minor axis moments and torsions and the likes, you have to go with the full versions of the frame analysis, or the simple steel beam can do a wee bit of torsion. Again, spring support, settling supports on continuous beams. Again, you're really talking about the free versions. I don't necessarily know how spring supports is going to work very well in the free version. I suppose you could have one fully encased and the other a slight spring, so it's semi prop cantilever. So that gives you an idea of the scope of the different programs. So I'm just going to come out of that, and we're going to start straight in to loading the MasterSeries. Here we go, 2018. Date is 19th of November. That is the current version, and we're running 64 bits. So, master frame. We're going to go into the beam designers first of all, because if I had to do a beam, a steel beam, I would prefer to do it in the steel beam designer, because it is a very finite controlled system. So open it up, and we can go in and create our own files. Now what we also have, if you go to your MasterSeries library, you will see that we have some simply configured frames for you in 1 and 2 and 3 and 6 span beams. So I could take a 2 span left cantilever and configure that. But what I'm going to do is I'm going to start from scratch. So I'm going to come back out and go to my directory, and I'm going to call it demo 1 and create the new file. Very simple. And here's what I get. Just zooming in and out, I get a 3 span beam with continuous, but we're also getting column action here, so the moments are slightly different in each side. First thing I'm going to do is customize this, and I'm going to go, and because I've got a nice wide screen, go for what I call 4 beams or 4 pictures. Next thing I'm going to do is I'm going to get rid of the columns. So support columns below, I'm going to put in 0. I'm going to tell it there are no upper columns, and I'm going to tell it that the conditions are pinned. So now we get pin, pin, pin. Happy. And we don't need to worry about that because we don't do that. Back to my beam data, and I want to come back down and make my default into a 1 span beam. So just get rid of the other 2 spans, and in this case just push those slightly apart and scale that down slightly. So scaling here and here and everything. So that's a basic section. I'm going to turn around here and tell it at this stage I'm going to actually work with S355, and I want my basic section to be a 254 146 by 31 and close. Obviously with the loading I've applied, that's quite heavy and that's quite onerous loading. I'm going to put something like 10 and to 7.5 as if it was a 3 meter width. What I now want to do is to come into the design code and tell it that I'm going to work to the EC3. With EC3 I'm going to work to the UK National Annex. And now that I've set all that up with my 1.35s and 1.5s, I am going to tell it that I want to use this beam as the current for every new beam. So use this as the default. So if I just come all the way out and say yes and yes and start a brand new file and call this demo 2 and create new, it will be based on this with my section size, my basic loading, my design code all set up automatically. So simple beam. In this case I'm going to put a cantilever on the end, so I'm going to go for a second span, 2 meter cantilever. At the minute you will see from the moments that it is assuming a prop here, but I'm going to make that end cantilever. So go to my supports, and rather than pinning anything, all I do is I say last as cantilever. So that's now cantilever, but because of the large span here we're getting it coming up, and you can see if I magnify my deflected diagram that I'm actually getting an uplift due to the large span. Now if I was to come back to my beam and change this from 6 to 4, now the large span is not as dominant and I do get a vertical deflection downwards from my cantilever. And this is one of the most important things to understand about cantilevers, is there's very, very rarely an encastre cantilever that has a full fixity. If I was to come along and turn around and say that my supports weren't pinned but fixed everywhere, then you're going to get fixed end moment here, fixed end moment here, and you then get just that deflection from the fixed end moment. Whereas you were getting a bit of pre-rotation due to this when I am in pin, and now that's dropping down, so it's actually a lesser deflection. So it's always quite wise. Now this program is very, very flexible and powerful, up to 16 spans. Everything will follow until you tell it otherwise. So if I decide out in my cantilever is only a balcony and it's 1.5 times 3 meters, it's only 4.5, I can then reduce that load there. Because it's continuous, I would also want to look at loading patterns so I get maximum, minimum, maximum, and I can see that I get a slightly higher moment here when I have patterns than when I don't. So I actually get a slightly larger sagging moment because the light load here and the heavy load here allows this to go down. Obviously cantilevers are determinate, so there's no real issue there. And it does all that itself. What else can this do? Very simply, I can come along and say, well, I want to put a point load on span 1, and I want that point load to be a dead load of a wall of 12 kilonewtons, and I want to put it at 2 meters out. So there comes my little load, and there is the slight increase there. If I change that from 10 to, or from 12 to 400 and something, you'll see now the point load's dominant, and that allows me to put my point load on. I'm going to put a second point load of 12, and this will be at 3 meters along. So I've got these 2 point loads, and I can change the scale of both the UDLs, and I can also ask it to give me values, give me distances. Now we're getting the value up here including the density, so we're getting slightly higher values due to the self weight of the beam. If I turn off density, I'm back down to my net values on the member. I can also put partially distributed loads, so I could then turn around and say, let's go for span 1 and put a live load of 1 kilonewton, and I'm going to put that between the 2 and 3 meters, so between 2 and 3, and there that slightly increases from 17 to 18. And again, I also have variable loads, so I can come along and say in span 1 I want it to start at 0.5, end at 1.5, just so we can see it, and it's going to have a finishing value of 50. So there we go, from 0 to 50, from 10 to 50, or if you want it to be really weird, you can swap them around so that they're switching back and forwards on that. So you can work that away. That's the live and the dead, and play around with those values as you see fit. I'm going to take off the partial UDL, or sorry, the trapezoidal, and I'm going to take off my partially distributed load, just tick there, and just look at the 2 loads, the 2 point loads plus my UDLs. Now if this wasn't a corridor with 2 walls but something else that you wanted to check what was the influence of that, you can say, well, what is going to give me the worst deflection location? And if I was to turn around and say this isn't span 1 but span 0, everything now is referenced from the origin, so I could give it a 5 meter length to put it along over here. But the nice thing now is in 100 millimeter increments, I can then start using the left and the right, and I can move a load by 100 mil or all loads by 100 mil. So it's graphically only showing the one load there at the minute. It should be moving both of those. I didn't have span 0 on that one as well, of course. There we go. So now we can move those loads, and as we move, it updates the information. So I could walk along to see where is the worst location for deflection, and we're getting 10.9, we're getting 11 mil, we're getting 11.1, and we're there. So it's in around here is where the worst deflection is going to be. And if we wanted to minimize the load, obviously you and I know as engineers, you straddle it over that support. So you would make it there. So you can walk along and you can see the effect of any location of any load. And the trick is to use span 0 rather than the physical span number to do that. I can also do this the opposite. I can look at the supports and I can say, well, let's take support 2, and where do I need to put it? And I can move my supports left and right. So coming back 2.1, 2 meters. So I can also move those back and forwards. So that's a very powerful WYSIWYG. What you see is what you can get for your results. Now, we are looking at all loading cases. We're looking at an envelope. We could look at all members loaded. So all maximum gives us 55. And then we go for maximum minimum, which gives us that larger value on the alternate loading of 64. And then we go for minimum maximum, which gives us 29, but gives us the maximum amount here, which will be the same as the all spans loaded case. So all cases. And likewise for deflections. Now, what to go into design? Steel design, very simply, very straightforward. In I come. And here I have my beams. And because it's beam in Master Beam, it knows what it is, it knows how to set it up design wise. So it's looking at this first span and it's going to do two different checks. It's going to do the appendix G and I just put a wee dot there so we can know where the beam ends. So looking at our design check, we can look at our beam and beam portion. We can see it's assumed that it's fully restrained. I'm happy with that. Or I could have said, well, actually, it's only restrained every 2 meters, which means it's restrained there or there. And I'm coming back to fully restrained. So fully restrained, I will see that I can now work with this section. And I can look at my section sizes and I can interactively decide, could I get away? And of course I could get away with a lighter section. And that now works, or sorry, doesn't work in deflection 1/360. That does work. So the 203, 133, 30 is going to work. Now I click on the member again and I come to the appendix G for the unrestrained compression flange due to the hugging, and it's fine. And now I move to the second member and I see that for the 203, 133, 30 it also works. Now at this moment in time I need to just have a quick check. It is a cantilever free for warping, and in fact you could set that down to 180 for a cantilever because it's half of the curvature. And you could also argue, because it's a cantilever, it is not fully restrained, it is 1L throughout its full length, and even at 1L it is fully working designed. So that's your design, and as we were changing the section sizes, it was automatically updating the analysis for us. But just to make sure, we're going to go and reanalyze and make sure we get the full continuity all working happily in our members. And of course we have auto design. You have this member button, it'll size it up and find that that was the shallowest section that works. If I went for by weight order, it would find the 22 works, but no, I don't like it. It's a wee bit unstable in the flange. I prefer it to be the slightly heavier section with a nice wide flange. And we can do that on one member or all members. And one of the functions is by default in these programs is that it tells us that we're using one section for all spans. So we're going to use the same section size throughout, which normally makes sense. So that is how quick and simple and easy it is to do a simple 2-span beam and cantilever. So I want to put that out, and I want to print the design output. I'm going to print, since it's only a small amount of work, all 4 outputs, and in fact I don't need the last appendix G because it doesn't apply because it's a cantilever. And I'm going to print that. I'm just going to say print the checks, and I'm printing to our MasterSeries printer, and print, and then I have 3 pages here of output, and I can just close that. And I'm just going to, I always like to save it in the desktop so I can kill it again quite easily. If I can get the desktop, there I go. And we're going to call it demo 2, same file name, and here we go. So very simply, we have our loading, our critical forces, and our design check, fully restrained, no questions. We have our appendix G on that member again, and its full design check. And then you have your cantilever with its unrestrained design check, all done very quick and sweet and fast. And that is your steel design. Naturally, you can print out the bending moment and shear force diagrams if you so desired, so you could go print and print current and ask to print those diagrams. But I'll just save time and not bother doing that now. Okay, that is one program. What I now want to walk through, and I'm going to do this a lot quicker, is concrete design. So, the very popular concrete beam designer. And I'm going to go for a new file, demo 1, create new, and it's already been set up as a default. I'm going to say it's a 5.6, a 4.9, and a 6.5 meter lengths, and it's going to be a 600 by 350 wide with this loading, and this loading is our dead and live on top of our self weight. It is at the minute to BS. I'm going to say no. We are working to Eurocode patterned loading and add self weight into that. And there we go with our hugging and sagging moments as we expect. And this is a great program. This moving of all the other inputs the same as the steel design. One of the advantages of this is if you're doing ground beams on piles, you can move your pile supports about to average out if you couldn't take 440, you could move that pile across so that you got under 400, hopefully, as your load. So I'm coming down, and it's not disappearing down very fast at the minute. Actually, the reason for that is because it's only at a hundredth of an increment, so a thousandth. There we go. That's 10. There we go. 1 meter at a time. Back to my data. Make that. Take out the extra zeros. Now I go to my supports. Now when I start to move, you'll see I'm going the wrong way. Coming down, 4, and now we have our 2 supports on our ground beam below the 400 kilonewtons. So very, very useful tool. I'm going to push that back over again. Give me a longer and a shorter span. Everything else is identical. So let's just go into the concrete design. Concrete design. A wee bit of setting up to do in this, because we need to tell it a couple of rules. First of all, I'm going to walk from left to right. When I'm doing my design, I'm going to work for 16s, and I'm going to work with 4 bars, and I'm going to try and work with 4 bars throughout with 2 legs. I am going to accept 30 cover because it's not a ground beam in this case. I don't have any columns and pads. Curtailment, I'm going to go for simple detailed curtailment, with the top and bottom bars going to the supports with lacers. And I am going to have no odd numbers of bars, because certainly in 450 wide beams, if it was a ground beam, you don't want to have that 3rd bar needing an extra link if you can get away with it. And I'm not going to go through all of these settings because it would take forever. Sidebars, no, I don't have any sidebars. EC2, scheduling to 8666, high yield 500 Bs, and we're going to go for 3240 as our concrete grade. Everything else I'm going to be happy with. I'm going to do out my design at 40 increments, and I'm going to detail to the nearest 100 millimeters. And don't have levels, don't have cranks. I'm just going to say OK. Off it goes, and it's just giving us a little warning. And I think we're into very heavy steel. For my loading, I probably need it. Actually, I got my directions the wrong way round. So, out of this, back to here, and it is 350 wide, 600 deep, and a little shortcut to design is in here. And we should now find, if we do an auto design, that we've got a more sensible 225s and 220s with 416s, 2s on these, and then we have the same. And at this moment, if I look at my cover, it's assuming that the steel coming in the other direction is dropping, and I don't really want that. And laps, cranks and kicks is not laps, beam detailing. There is an option. Yes, it's in the covers, isn't it? Yep. Additional at supports. I don't want any additional at supports. It's not needed. Say OK, so it's all there. And at the minute it's put 4 and 4. Could I get away with 425s? I could. Could I get away with 420s? I could. Could I get away with 416s? I could. And at this end, I'm in the middle span. Could I get away? And I'm just going to make these. Just left and right mouse button is what I use to change the diameters. And I'm coming down here. And because I got a deeper beam, it's a lot happier. And this is a more sensible arrangement, or just R to do all of the beams again, and this makes much more sense. 416s, 416s, 216s and 220s. I might decide down to 0, up to 420s. Keep it simple. And then we have 416s throughout here. 416s coming into 420s. I could drop that bar out and lap these at the center if I wanted to. It's all there for you, fully flexible. So if I decided I wanted to get rid of this bar, it's then going to try and lap these together. So it's taking that bar out. I can then say, let's make this bar longer. And I got two options here. I can either just drag the bar. If I use the lasso, I can drag both parts of the bar into the mid-span, and it's just giving me a slightly longer lap length in that. So that's how simple the concrete is. Now if you want detailed guidance on using the concrete itself, you go and look at the concrete webinar. I'm just giving you a flavor of what we can do here today. And naturally, not only that, we can take this and we could export a DXF file of our detailed reinforcement. So RC details, export, and I'm going to export it to 8666, and off I go, and hopefully I should get something sensible coming out in my detail. AutoCAD 2018, and here we go, all our bars all detailed up with marks and kicks and everything for you, and sections annotated with the bars. So very straightforward, all to scale. And naturally you can also produce a bar schedule that would match that set of arrangements, and I can say schedule, and there we go with a set of rebar for that cage that we exported. So that's how simple the concrete is, and that was covered in 6 minutes compared to the steel design. The next one is obvious, and it's the timber. The timber design uses the exact same interface, Beam Designer. I'm going to take a brand new file, any old file name, and I'm going to come in this case I'm going to go for a single span beam. I'm going to take out my supports, I'm going to make it pinned, and I'm going to have no supports. So I'm used to the simple beam, and I can then come along and design that. So looking at my beam data, it's a beam, so it's going to be pretty chunky. I don't believe that I would want anything like that, so I'm going to go for a 75 by 225 with this loading on it. And obviously the deflections are quite high under Ultimate and Service. And take my little shortcut into my design, because I haven't really stipulated all the details here yet. Would help if we work to Eurocode, and obviously I go up and save that, and it will be my default from then. So use current, and that sets that up for me. Into my timber, and here I go. Of course I've got problems because I've got quite heavy loads on this beam. Material specification is only C16. I'm going to go for glulam 24H, and I'll see I have some moment capacity problems still. So obviously I need something a bit chunkier, so 125 wide, and for this beam 300 deep, and that works. And we could also say that it was load sharing between different loads and get a slight reduction in all our values. It's medium term, internal, and one piece doesn't apply, and that's your timber designed for you. Very straightforward. And you can play around with one or two of the length factors, and the bearing lengths. Default is 75 mil or 3 inches in old money, and things like that. But timber is again very straightforward. The one of the big advantages of this is that with this beam designer in the timber, you also get the standalone version for doing flitched beams, which we will look at later on. So that's our beam designers. Doesn't matter if it is the commercial version or the 3-span power pad version or the free version, it is all the same functionality. For the free versions, all you need to do is delete any additional spans and work with the one span. And that's it, done. So now, as an alternative, we can look at master frame. So looking at master frame, okay, so beams, I don't have any. Trusses, yeah. Frames, I've got one or two simple beams in here for you to play with. You're going to see nothing else there. Library files, well, in library files, if we go to beams, we have nothing. We go to frames, we have beams, we have pads, and we have columns and simple construction. So that's a copy of library inside my area. If we go to the real library, we will see that we've got some simple beams set up here. A timber purlin or a steel PFC purlin. So let's look at why we'd want to use this program rather than the simple programs. Well, it's more flexible. You can do more things because you're going to get a minimum of 50 members unless you're using the free 1-span system. So you can look at cruciform members, you can look at things like that. But let's look again at the loading on this, member loading. And again, I've got a couple of UDLs, and in this case I've got dead, live and wind in 3 different directions. The dead is gravity, so it's measured per meter long. In this case, because it's horizontal, it doesn't really matter. Live is measured per meter length, so that's the same, and then wind is normal to the member, so perpendicular to the member. Now, if I was to look at this member in side view, you would see it's actually been rotated, so that normal to member load is coming in down through the member as you would get a normal purlin. So let's looking at the section, we have this thing called beta angles. So if you look at the properties, you have the materials, the cross-section orientation is this beta value, and obviously the default is 0, but I put in 30 degrees, so I have this on an incline. So even our dead and live loads are all going to induce asymmetric, biaxial bending. So this is something we cannot do in the beam designers because we have moments in 2 directions. We could also come along back to this member and for whatever harebrained reason put this back, and I'm just going to turn on the supports. So if I look, I have not avoided, I'll change those supports in a minute. I'm going to put an axial load here pushing it, so I'm going to put a point load. I'm going to call it a wind load, and it's going to be in the X direction, and it's going to be minus 5 kilonewtons, and it's going to be at the full length of the member, which is 5 meters. So 5, so it's going to be out here pushing. So I didn't get that 5 there. 5. It's going to be out there pushing along the member. Now, I want to just go and look at my pins, restraints, and I will see that in this end I have vertical and horizontal. I don't want a horizontal restraint, so I can get a compression into the member. I'll have a rotational because I need that. If I look at the other end by going to the second support, it is, well, actually we'd swap them around. It's now got the Y support. So that was the roller, but I've now just switched them around. Okay, that's all perfectly good. Analyze, static analysis. And I've given it a whole multitude of loading cases because I've got wind analysis on it. And it's probably worthwhile talking about loading cases. In the Beam Designers, we had to look after the loading cases were all looked after for us because it's very simple, it's continuous, or it's single member, and it's just alternate patterns. In here, you actually either create your loading cases, or very simply from loading cases come in and ask it to bring the default cases in for you. One of the nice things is once you've set one of these up, you bring them in again and again and again and use them, and there is the Eurocode, thank goodness. So I'm now going to go to Analysis, Static Analysis, and Plane Frame, and it's saying no, you've out of plane moments. Your member's at an angle, your loading is at an angle, you cannot analyze it as that. So analyze static space frame, and thus why we had to put the torsional restraint onto it. So in here we go and look at our results, graphical, very straightforward. Bending moments, well, always worthwhile looking at these in two directions. As we can see, are two sets of forces being applied, and we can see our different loading cases. And we go to the ultimate envelope, we will see in here a series of different major and minor axes. Moments, obviously the vertical is more critical than the horizontal in its loading, but obviously that's the strong axis of the member. Deflected shape, ooh, let's not magnify it by a lot, take it back down 1 to 1 and show that with deflected member, and we can even put on some values and see it's moving by 23 mil in span. Now design is similar, just come out of that and we go into design, steel member design, and again, because it's a single span beam, it kind of knows what to do. So lateral restraints, it's going to be 1L and it works, or it could be fully restrained and it'll definitely work, but 1L and it works. And we will then see from an auto design point of view, could we have got a way with a smaller 100 by 50, which is less than half the strength, and it says nope, deflection is now critical. So moving up one section size at a time, we will see we're at 24. So here we have the optimum section is a 150 by 90 by 24, which I think is actually heavier than my 200 by 75, so I'm going to stick with it as long as I have the ability to take that higher headroom. I'm going to have a better reserve. So in summary, auto size by weight tells us it's the 200 by 75. By depth, it's actually by depth gone to the same, but I know that that would actually have worked. Oh no, it didn't work. Sorry, I'm talking rubbish. I missed it there. So 200 by 75 PFC in grade 355. Naturally, if you were down to grade 275, doesn't make a difference because it's deflection that is, as you know, in long, thin, lightly loaded members is normally critical. So deflection is yield strength doesn't help deflection, and that is your frame design. But bear in mind, this does not have to be a single beam. It does not have to be a simple beam. It could be a whole frame of beams, it could be a frame because you've got at least the 50 member design. If I was to go to open and looking at concrete back into my frames, I have some concrete frames here. Okay, that was an educational one, we'll forget about that. Concrete. Let me see, I'm after a little simple, there we go, concrete frame. Get file. These are all beams. These are all beams with some support. So this is supporting beams off each other. This has got a crank in it. These are cantilevers, and this is supporting itself by the back beam. And this is supporting this cantilever by its back beam. They're all simple beams. They're all loaded very straightforward. And I am going to look at the global analysis options for you, and one thing we've done is to ignore torsional stiffness. If I don't ignore torsional stiffness and I go through and analyze, and it's just two loading cases, I haven't bothered with putting in alternate load patterns at this stage, and I go to results, graphical, and look at my bending moments. Okay, let's get that scale down a wee bit, but let's also hatch that a bit more. And what you're seeing is that at every instance you're getting little kicks, because this little kick here is equal to this kick here. Well, the torsion in this member, this kick is going to put a torsion here, and this member, this kick here, is going to put a torsion in these two members. So we're going to get torsions all over the place, and that's going to cause you a wee bit of fun in your design. And likewise, you can see here we're getting massive kicks between spans because of this torsion that we're exhibiting. If I was to come out and go into the concrete design, concrete beam design, you'll see for any member here we're going to be designing it, but when we look at the results, oops, sorry, wrong button, results, we will be looking at the member with its torsion. If it's significant. And there we go, torsional design. This member, because of these cantilevers, has got significant torsion, and therefore it's doing a check, and it's using this, and it's using this, so it's using 800, it needs 272 mil top and bottom just for the torsion. So it's putting those in as additional steel and then ignoring them in the steel design. So it's doing a full torsional design. That also means that we need torsional links, which are the longer links. Whereas if the frame can work without any torsion, then you're allowed to analyze it without torsion. So ignore torsional stiffness and say OK. If I now reanalyze static space frame, I have got an instability, which I was not expecting. Right, theta 12, theta z, that's rather embarrassing. So in here we must have a release somewhere in here. So if I go to restraints, end releases, and there are no end releases, yeah, there are none that have end releases. If I go to static supports, yeah, that should be giving me an answer that works. I wonder, is there instability because of the crank? And if I was to put those two onto a straight line, would that work? Um, Sometimes you can't ignore torsion, and obviously this appears to be a case of an example where you cannot ignore torsion. So I'm just going to accept that I can't ignore torsion at this moment in time. So global, back in again, take that out, and say OK. So again, go ahead and design as normal. Oops, sorry. So that is your frame analysis. And from a commercial point of view, you have the beam designers. That's the one I spent most time on, the 16 span steel beam designer. The concrete is identical, continuous beams, and also the timber. Now, timber will normally be 1 or 2 spans, possibly 3. The 2 span, obviously, to get you your cantilever with a back beam, quite useful. And then, as an alternative, you have the frame analysis with the 50 member design and your steel or concrete or timber member design. PowerPad includes 3 span beam designers plus 100 member frame analysis. There's also a PowerPad 500 which logically takes you up to 500 members. And then the free software is basically 1 span in the beam designers, but not the timber beam designer, only the steel and concrete beam designers. And for frames, 1 span and 1 span with steel or concrete. So little concrete beams and lintels, yes. Little steel beams and lintels, yes. And the difference between these two is this is easier, that can apply more complex loading. Can we create our own cross section of steel beams? You can create 2 sets of sections, and they're both really explained best in the master frame. So if I go into even the steel purlin, if I went to properties and member properties, I have all the standard sections, UBs, UCs, RSJs, even flats and round bars, universal bearing piles, the European IPEs. You can load in the American sections as a separate library or an alternative library. You can load in the Chinese sections as an alternate library. And you have all the T's and the channels. What you can also do is you can add to these lists. If you have another UB you want to add, you can customize and add it to your database. If you want to bring in the historic sections, and you can import them on bulk. But we also have the built-up sections. So if I was doing, and it clearly might make more sense to have this with a beta angle of 0, and then back to the section. I go to a built-up section. I can say give me a 250 by 200 wide with a 300 wide bottom flange, and make the bottom flange 50mm thick just for the fun of it, so I can make up my own welded section. We can also do cell forms, we can also do discrete openings, but from a customization you can also go and then put another section on it. So I could put a top plate that is 300, make it 10 by 300, and that's analyzing. So take off that extra plate and I'll just go back to UBs, and it goes to the big one. Okay. We also obviously use the concrete and timber, and the concrete can be different shapes. You also have something called user sections, otherwise known as a blob, where you have an area, an IX, an IY, a J, and an E, and if you want to, shear area. So you can input your own non-standard sections. And again, you can import those from a library and you can edit the open library of those. So, but you cannot design these user sections. They are just for analysis. Are the loading cases indicated standard within the program, and can you edit these? They are standard, you can edit them. You can actually set up your own loading case patterns. And I actually, if I was to take this set of ground beams and I wanted to do a pattern loading, I might come in to my loading cases and I could go and add in some cases. So I could add in another case and call it Fred, and then I could go to the combination and I could say that it's, well, just use the buttons, 1.35, 0.9, 1.5 and 0.9, and use that, and I can edit those. I can also come into the loading cases and I can suspend cases, but I can also import cases from a previous file. So I could say go and bring in the cases, or I can import them from my library of different weird, and these are just the BS ones that are in this library, but I could go and say import from another file, and looking at this view I could come up and I could say let's go back all the way to the library and loading cases, and I've got loading cases, that's for FE, this is concrete, and that's giving you 1.4, so that's BS, that's your 1.25s, this is your 1.35, so I can say yeah, bring those in and replace all my loading cases. So I can bring in those from another file that I've saved just into a directory called library and use those. So very simply you can create your own loading cases. Can we design using open and multiple links? Absolutely, very good question there. Yes, the links that you can design, and I'm just going to come back out of that and go straight to, it's going to give me slightly weirdness because I've changed my combinations, but it should give me enough to get me by space frame. And yeah, it should be, well, it could have been in Grillage actually. And if I look at any of these, I've got one link. I can go to my links and I can say, well, actually, I want 3 links, 4 links, and then need to just put the section arrow at the right place and tell it that we're going to use a couple of those. So we're now getting into 4 links in the system and 5. So we're now into 5 links. We can also, from the configuration, turn around and tell it from the beam curtailment that we want to use open links with closures. Very popular in ground beams and beams in general, where you create most of it and then drop in the splice bars and then close over the cage, so you wouldn't have the links closing until you'd finished with your top bars. Yes, that's available. You can do the beams as slabs, so you can say no links, and you can even do them with links that are of equal width. I don't like that. We can use single leg links, which means that we're actually not using a square bar here, but a couple of U bars with long legs here and here. And we'll just turn all that off, and we can also use them with U bars rather than shape 85s. That's 85s in the old money. So there's a lot of different configurations that are available, and you'll see now I've got the U bar, I've got 5 legs. Obviously it's going to tell me that I've got problems, I haven't got a restraint for that link and things like that. So yes, it's very configurable from that point of view. In the beam design there was a B and an H, but there was also something else. Well, that's to do with the fact if you went for a T section, you would have the breadth of the web and then the breadth of the flange and the height of the flange and the overall height of the section. Very simple. Is there a module to design EC4 slabs and beams and composite. Yes, it's the one program I said we weren't covering today, our composite design. I will put a link in the answers to all the questions to the composite design. It's very, very straightforward. Free student version, so they can use it with their coursework. Very good question, Baksan. Very, very simple. There we come. Okay, two things. First of all, back to MasterSeries. Home screen. Just going to scale that down a wee bit so we can see it. And easiest way to find this is just to go to search and type in the word student, education, or other similar. So PowerPad Student Edition. Go straight to the link. And I think Martin's already put the link in there for you. And if you scroll down, it tells you download here. It also tells you download here tab. So you click on the download here and you now get your latest updates, you get your latest patch, and because it's more than just beams, you get your Revit link if you want that. However, I will warn everybody that student versions are not compatible with the educational version, with the commercial versions. So don't try what somebody did and try use it as an extra copy on in their office, because the files are encrypted. And also the student versions are not available on Macs. I am sorry, at this moment in time the licensing won't run on a Mac, unfortunately. So that is how you get the student versions. Now, can the PowerPad students do continuous beams? Absolutely, you can do. In the PowerPad, which is the student version as well, you have the 3-span continuous beams inside the little beam designers, or you use the frame analysis to do your multiple continuous beams. If I was to come back here to my frame, come all the way to concrete and save that and take a brand new file and call it, put it out here out of the way, new file, give it a name, create. I can say give me a continuous beam, give me alternate loading, make one of them, so yes, make one of them cantilever and make the first one fixed, so it's fixed, pin, cantilever, and then I can come in and put in some basic loads and go through and do my design, and it's all automatic for you. Best to put some basic loads on, and then you will see when you say apply that the loading in the load diagrams, which are really only applicable in the frames, are able to do, and this is by default BS, all the different patterns of max, min, max. However, if I just go and say design code Eurocode, yes, and choose the simpler 1.35s, then when I come back to my loads, updated the names, it's updated the load factors, and everything is as you wanted. Again, pattern loading and the service equivalents all done for you. So PowerPad would allow you to do 100 member continuous beam. Haunches can be checked, Andras, but tapered members wouldn't be checked other than this, a tapered, as in haunched tapered member. So if we were not in concrete but in the steel, I mean, certainly we can come along into our properties and go to, because we haven't specified if it's steel or concrete yet, tell it that this is steel, tell it that it is not uniform but a double haunch, at which point You're going to tell it the length that's haunched. I'm going to go for 1 meter haunched. Length 2 that's haunched is 1 meter, and then the ratios is 2 and 2. So 2 times the serial for a meter and a meter, and I'm going to make that 1.75 so you can see the difference. So that's totally doable. If you were to go and say, no, I want a single haunch, you could actually do a single haunch where you say actually it's from 0 uniform to 0 uniform. If you look at the picture, it's the 2 uniform distances now, and I'm going to go from 2 to 1, or I'm going to go from 2 to 0.5, or I'm going to go from 1 to 0.5, and it takes it all the way down, and it's for you. So you can do, to an extent, tapered sections in the steel, but not at the moment in the concrete, and that can be fully designed. National annexes, absolutely, Nicola. We have the British national annexes. We're about to add in more directly, but you can add in your own. Now, as users of the software, it's important to understand where to get more information. And if I go in and log into the client area, you have areas like technical notes. But more importantly, you have videos. And if I go to videos, you will see you have videos on importing a file, on, well, for wind obviously, on that. If I was to go for Euro and type in Euro code, you've got how to create your own national annex document, and it talks you through the wee short 1 minute process, 2 minute process of adding in as a duplicate your own national annex. Because all you're doing, and if I just maximize that, all you're doing is you're setting what the favorable and unfavorable values are that you want to use. Most of them will come from the standard norm, and each country only changes 1 or 2. But that allows you to make your own national annex from any country around the world to use the Euro codes, because I know that certain Middle Eastern countries use Euro codes, even though they're not part of the Euro code organization directly. The other thing I wanted to show you was using the different databases. As a video here, but if I go back up to the client area and into technical notes, downloads. In downloads, as well as downloading the latest versions of the software, you have the facility to download the sample files. Now, I was talking about the sample beams. There's the sample beams. There's the sample concrete frame. There's some simple connections. So those sample beams are for the beam designers as defaults. So you can pull those in as examples. Those are trusses, all the different truss types that we can handle by default from our library. That's where they are. But most of them are installed these days directly from the during installation into the library directory, which is program files, MasterSeries library, and then what you need. There's also an update for those who want to add in the newer enormous section sizes. So ladies and gentlemen, I have talked quite a lot. I can still see that quite a few of you are still hanging on to my words. But other than that, there's nothing else that I need to do. So if you want to try the software, just go to start your free trial. If you only want the free Beam Designer, just ask for that. You get a 14-day trial of the software. If you need me or any of my colleagues to talk to you about upgrading your system, adding in the Beam Designers, give me a shout. My name, as I say, is Tommy White. It's tommy@masterseries.com. Very, very simple. If you need to talk to the guys in the help desk, it's help@masterseries.com. Thank you very, very much. And any questions, just send them all in to me. Thank you.